The topic for discussion is calculations of number of particles, that is, number of ions in solution of acid, base or salt, and the number of molecules of CO2 gas involved during acid-base titration reaction. Note that for calculations of number of ions and number of molecules of CO2 gas involved, the examiner gives the value of Avogadro constant, which is 6.02 times 10 raised to about 23. While for the volume of CO2 gas involved, the examiner gives the value of molar volume constant, which is 22.4 dm cube. For this topic, I want to look at an example of past SSCE questions on calculations involving number of sodium ions and the number of molecules of CO2 gas. On the tutorial board is a question which is as follows. A is a solution containing 0.05 mole per dm cube of H2SO4 acid. B contains anhydrous Na2CO3 solution. Calculate the 1. Concentration of B in mole per dm cube. 2. Number of sodium ions in 1 dm cube of B. 3. Number of molecules of CO2 in 1 dm cube of B. Note the following. The examiner gives the equation of reaction, and for this reaction, 1 mole of H2SO4 plus 1 mole of Na2CO3 gives 1 mole of Na2SO4 plus 1 mole of CO2 plus 1 mole of H2O. In this given equation, the number of mole of H2SO4 acid, that is Na, is equal to 1. The number of mole of Na2CO3 base, that is Nb, is equal to 1. The average volume of acid used or acid titer is taken as 20.50 cm cube. The volume of base pipetted is taken as 25 cm cube. On the tutorial board are the steps taken in calculations of number of ions. Students can write this out for your private studies. On the tutorial board, question 1 is calculation of concentration of B in mole per dm cube. Note that no information is given on B. Therefore, concentration of B in mole per dm cube is calculated using Ca times Va divided by Cb times Vb equal to Na divided by Nb, as shown on the tutorial board. Concentration of B in mole per dm cube is represented by Cb. To calculate Cb, make Cb the subject of the formula, and we have on the tutorial board Cb equal to Ca multiplied by Va multiplied by Nb divided by Vb multiplied by Na. Substitute all values for Ca, Va, Na, Vb, Nb into the formula for Cb, and we have on the tutorial board Cb equal to 0.05 for Ca multiplied by 20.50 for Va multiplied by 1 for Nb divided by 25 for Vb multiplied by 1 for Na, and the answer is 0.041 mole per dm cube. Question 2 on the tutorial board is calculations of number of sodium ions in 1 dm cube of B, which contain 0.041 mole, which is the concentration of B in mole per dm cube. For this calculation, we use the ionization equation for 1 mole of Na2CO3. That is, 1 mole of Na2CO3 gives 2 moles of sodium ion plus 1 mole of triosocarbonate 4 ion. Express the number of sodium ion in the ionization equation for 1 mole of Na2CO3 in terms of Avogadro constant, and we have on the tutorial board. If 1 mole of Na2CO3 gives 2 moles times 6.02 times 10 raised to power 23 number of sodium ions. Therefore, in the reaction, 0.041 mole of Na2CO3 will give 2 times 6.02 times 10 raised to power 23 times 0.041, and the answer is 0.49 times 10 raised to power 23. Question 3 on the tutorial board is the calculation of number of molecules of CO2 in 1 dm cube of B, which contain 0.041 mole, which is the concentration of B in mole per dm cube. For this calculation, we use the stoichiometric equation for the reaction, that is 1 mole of Na2CO3 gives 1 mole of CO2. Express the number of mole of CO2 in the stoichiometric equation in terms of the Avogadro constant, and we have on the tutorial board, if 1 mole of Na2CO3 gives 1 mole times 6.02 times 10 raised to power 23 number of CO2 molecules. Therefore, in the reaction, 0.041 mole of Na2CO3 will give 1 times 6.02 times 10 raised to power 23 times 0.041, and the answer is 0.246 times 10 raised to power 23.